Welcome to the mathematics class of 2020, and we are to discuss on one of the topic in pre-calculus. So, hello there, I'm your teacher, Ma'am Clarissa. Let us try to observe what type of conic section that these objects represent. First, we have the ball. Second, there's this lampshade. And third, it's a sample of a bridge. Now, can you name what type of conic section these objects represents? Correct, it's hyperbola. Based from the given sample figures, can you describe a hyperbola? Hyperbola is the locus or set of all points in the plane where the absolute difference of whose distances from two fixed points is a constant. Do you have any idea on how to sketch the graph of hyperbola and how to obtain the measurements to make the curve symmetrical? Before we sketch the graph of hyperbola, here are the point of references and its meaning. First, we need to know the vertices. We labeled it as V sub 1 and V sub 2, also called a transverse axis. And the basis of getting the point is by using the distance from center to a vertex. Our vertex represents variable A. Next is what we call the conjugate axis. That labeled as W sub 1 and W sub 2. Now using the distance from center to an end of the conjugate axis, that represents our variable b. Third, we have what we call the foci. We have also two, that is f sub 1 and f sub 2. Now using the distance from center to a focus, our focus represents variable c. Lastly, it is also very important for us to know the width of the hyperbola, and that is now getting the value of the latus rectum. It is the chord through either focus perpendicular to the transverse axis. Now its length is equal to 2b squared over a. Now getting the half distance is equal to b squared over a. We have the same formula in ellipse, guys. After getting the point of reference, it is also important to know the line of its reference, and we call it as the asymptote. It is a straight line which the curve approaches indefinitely near but never touches. Let's take a look on the first illustration of hyperbola. It's the horizontal transverse axis. It has a formula x squared over a squared minus y squared over b squared equals 1. Now let's name the parts in the figure. The two intersecting diagonal lines are called the asymptotes. The formulas there we have y equals negative b over a of x and y equals positive b over a of x. They both intersect at the point of origin called the center with an ordered pair 0 and 0. Since we're dealing with horizontal transverse axis, the vertices lies along the x-axis with the vertex negative a and 0 and positive a and 0. The same is true with the two focus or the foci, with an ordered pair negative c and 0 and positive c and 0. It is also very important for us to know the width of the hyperbola, and we term that as the latus rectum. Now the characteristics of the horizontal transverse axis, wherein the curve opens to the left and right of the graph, and also the value of C that represents the focus is greater than the value of variable A that represents the value of the vertex. And in order for you to get the value of C, you need to use the Pythagorean theorem. And thus we have the formula there, C squared is equal to A squared plus B squared. Next hyperbola illustration is the vertical transverse axis, where the center is at the point of origin with an ordered pair 0 and 0. As you can see in the graph, the point of vertices and the foci lies along the y-axis. Notice that the curve opens upward and downward. Let's have the first given example. How are you going to sketch the graph of this equation? X squared over 9 minus y squared over 16 equals 1. What does this equation illustrate? Now, your basis to determine the type of its illustration is the first term, and your first numerator is x squared, and the denominator is a squared equals 9. So therefore, the vertices lies along the x-axis. So we have there the solution in the equation x squared over 9 minus y squared over 16 equals 1. Notice that we first took the values of a, b, and c. A here is the variable representing the value for our vertices. And since we have a squared that is equal to 9, we just get the square root of 9 and that is equal to 3. Notice now that the vertices, since this 9 here, I mentioned a while ago that that belongs to the x-axis. So we have there, we count 1, 2, 3 units. So we have there the first vertex, and we also count from the point of origin 0, -1, -2, -3. So we have your v sub 2. Okay, we have the ordered pair -3 and 0. Okay, next. For our conjugate axis, that represents now your variable b. So for your b squared, we have 16. So we just get the square root of 16 that is equal to 4. Now, since we're done with getting the vertices, and that is also known as the transverse axis, so we need to count 4 units upward and downward from the point of origin. So we have 0, positive 1, 2, 3, and 4. So we represent this as W sub 1. And then we have -1, -2, -3, -4. So that is our W sub 2. Okay? So we have there the ordered pair. We have, 0 and it's my first time to write. So we have 0 and -4. And we have 0 and positive 4 a while ago. And we have 0 and -4. Okay, so that is your conjugate axis. So our vertices a while ago, we have, let's write the points, the ordered pair. So we have 3 and 0. Okay, so we have here -3. Sorry, that that looks like not -3. So we have -3 and 0. So sorry, please bear with my penmanship. Oh my gosh. And 0. Okay, now, so since we're done with the values of a and b, so we are to create, or we are to draw what we call auxiliary rectangle. That is our basis for us to draw also the asymptotes. Okay? Now also, once you're done having your values of a and b, now for you to get the value of c, this is your basis for you to plot the focus. So you just get the sum of the square root of 9 and 16. So that is square root of 25, and that is equal to 5. So from there, you just count again from the point of origin. You count along the x-axis 0, 1, 2, 3, 4, 5. There you have it, guys. You have there the focus sub 1. So this is your, oh my god. So we have there your 5 and 0. My effort. Oh my god. Kaloka naman to. 5 and 0. And then on the other side, we have 0, -1, -2, 3, -4, and -5. So this is your f sub 2. Okay? You can interchange if you want to. This will serve as your f sub 1 or f sub 2. It's just okay. It doesn't matter. So we have -5 and 0. Okay? So there you have it. Now, next is to get the equation of the asymptotes. So that is just equal to rise over run, positive and negative rise over run. So that is your B, that is your rise. Okay, so we rise up at 4 units and we run at 3 units. So that is the equation now of your asymptotes. And for us to get the latus rectum, so you just take the half of the latus rectum. So we have there, the half of the latus rectum, guys, is positive and negative b squared. So our b squared is 16 over your a, that is equal to the value of a already, that is equal to 3. So that is positive and negative 16 over 3. That is approximately equal to 5.33. So from this point, from the focus, so you just count 5.33. So we have approximately from this point. So you can now label it. So this is now your 5 for x. And for your y, that is 5.33. And from there also, we have another one that is from 5. Definitely, this gives you negative 5.33. Okay. And on the other side, we have, you just change the x value. That will now give you negative 5. And we have 5 and 5.33. Okay. And on the last part, we have negative 5 again. And that is negative 5.33. Oh my gosh, nanginginig. Okay na yan. Okay. So that is our first example. Now notice that this belongs to the horizontal transverse axis. So let's take the second equation. We have y squared over 16 minus x squared over 9 equals 1. Now what type of hyperbola is this? Is this going to be a vertical or the horizontal axis? Now once again, your basis is your first term. It is y squared over 16. So meaning to say your vertices lies along the y-axis. Therefore, this illustrates the vertical transverse axis. This is the complete solution of y squared over 16 minus x squared over 9 equals 1. First, notice the first term, it is y squared over 16. So 16 there represents your a squared. This will serve as your basis for you to get the value or the ordered pair of the vertices. And this lies along the y-axis since your numerator there is y squared. So you have there the values of a, b, and c. A there equals 4, b equals 3, and c, you just get the sum of the square root of 16 and 9. So you have the square root of 25, and that is equal to 5. So notice now in your graph, your A, your vertices, as well as your foci lies along the y-axis. And next, you have there your asymptotes. A while ago, your asymptotes formula was y equals positive and negative b over a of x. Now, what did you notice? It was switched into a over b because your rise now equals positive and negative 4 and your run equals 3. So it was 4 units upward from the point of origin and runs 3 units from the point of origin. So that is your asymptote. It is equal to y equals positive and negative 4/3 of x. So that is the equation. Next, you need also again to know the width of the hyperbola. So it's still the same formula. You have 1/2 of LR. So that is the variable of the latus rectum. It is equal to positive and negative b squared over a of x. So that is equal to positive and negative 9 over 4 of x, or that is approximately equal to positive and negative 2.25. So after getting the values already, you may now ready to plot the points and sketch the graph of this equation. Now notice that your hyperbola opens upward and downward. So this really belongs to the vertical transverse axis. I hope you learned something in today's lesson. Thank you for watching and listening. Goodbye.